So we are now on the last part of chapter 4, which is the moving loads. So beams and girders such as in a bridge or an overhead crane are subjected to moving concentrated loads which are at fixed distance with each other. So for example, we have a bridge with a certain span or with a certain length and dinadaan nito ng mga sasakyan like buses, trucks with a moving concentrated load. So for example, ito yung mga gulong ng sasakyan. It has a certain load which is moving all over the span. So the problem here is to determine the moment under each load when each load is in a position to cause a maximum moment. So from our previous section, we see that the maximum moment occurs at a point of zero shear. And for beams loaded with a concentrated loads, the point of zero shears usually occurs under a concentrated load, and so the maximum moment. So as I have discussed on the first part of this chapter, matatagpuan natin yung moment at the zero shear, or matatagpuan natin yung maximum moment at the zero shears. So the largest value of these moments governs the design of the beam. So kailangan nating kunin yung maximum moment on each concentrated load para yun yung maging guide natin in designing the beams. So we have a single moving load. So in single moving load, the maximum moment occurs when the load is at the midspan, and the maximum shear occurs when the load is very near the support. Matatagpuan natin yung maximum moment at the midspan and the maximum shear at very near the support. In which the maximum moment is equal to the load multiplied by the length all over 4, and the maximum shear is equal to the concentrated load. And then for two moving loads, the maximum shear occurs at the reaction when the larger load is over that support. So the maximum moment is given by a formula which is equal to in which the maximum moment is equal to the difference of the total load, or PB plus PS, multiplied by the total length minus the larger load multiplied by the fixed distance D is squared all over 4PL. So again, yung P natin dito is the summation PB and PS, and then yung D is the fixed distance. So on our example, I am not using this formula kasi I will show to you manually on how we will solve the maximum moment and the maximum shear. So gagamitin nyo lang itong formula na to in checking, but on your actual exam, I will let you use manual computations, and this is for checking only. So I will not be considering this one. This is used for checking your answers only. And then we have also three moving load or more moving loads. So it can be 4, 5, 6, 7, and so on. So in general, the bending moment under a particular load is a maximum when the center of the beam is midway between that load and the resultant of all loads then on the span. So we have, for example, 3 or 4 loads. Kukunin natin yung resultant of all the loads, and with this, we will compute the maximum moment under each load. So isa-isahin natin and use the biggest moments for the design. For example, we have 3 concentrated loads. I-design natin yung isa-isa, and kung ano man yung lalabas na biggest moments, it will be the one makakonsider in designing the beam. So the maximum shear occurs at the reaction where the resultant load is nearest. So usually it happens if the biggest load is over the support and as many as possible of the remaining loads are still on the span. So in determining the largest moment and shear, it is sometimes necessary to check the condition when the bigger loads are on the span and the rest of the smaller loads are outside. So, medyo mahirap intindihan on this part. So, let us move now on our example para mas maintindihan nyo. So, for example number 1, a truck with axle loads of 40 kN and 60 kN on a wheelbase of 5 meter rolls across a 10 meter span. Compute the maximum bending moment and the maximum shearing force. So, on this example, I will show you the first step or the first way on how we solve for the maximum moment and the maximum shear. And the second example, papakita ko naman yung second way on how we solve the maximum moment and the maximum shear. So, on the exam, it's either kung anong gamitin yung step, kung saan kayo mas convenient. Papakita ko na lang yung dalawang step. So, the first step, so this is the first way on how we solve for the maximum shear and the maximum moment by using the shear and moment diagram. So we have a 40 kN load and a 60 kN load. So kukunin natin yung resultant, which is equal to 60 plus 40. So it is equal to 100 kN. So ito yung ating resultant, which is equal to 100 kN. So the fixed distance of these two wheels or these two loads is equal to 5 meters. So yung distance ng ating resultant from 40 kN is considered as x, and this is 5 minus x. So we will determine the value of x here by having the summation of moment at r is equal to 0. So we have negative 40 multiplied by x plus 60 multiplied by 5 minus x is equal to 0. Therefore, x is equal to x is equal to 3 meters. So this is 3 meters. So 5 minus 3, so this is 2 meters. So let us take the maximum moment. So maximum moment at 40 kilonewton. So yung maximum moment at 40 kilonewton. So una is i-drawing natin yung full span ng ating bridge, for example. So we have R2, R1, and then ito yung ating center line, which is 5 meters. So this is 5 meters, this is 5 meters. So kung ko-consider natin yung 40 kilonewton, so dito yung position ng ating 40 kilonewton, which is 1.5 meters from the center line. So kukunin natin yung 1.5 meters, so we have still here 1.5 meters. And this is the resultant, which is equal to 100 kilonewton. And then 2 meters for 60 kilonewton. So we have 5 minus 2, 3 minus 1.5. So we have 1.5 meters pa dito. And at this part, 5 minus 1.5. So we still have 3.5 or 2.5. So we still have 2.5 meters. 2.5 meters. So, ang gagawin natin dito is to draw the shear and moment diagram. So, taking the summation of moment at R2 is equal to 0, we have R1 multiplied by 10 minus 40 multiplied by 1.5 plus 2 plus 1.5 plus 1.5 minus 60 of 1.5 is equal to 0. Therefore, the reaction 1 is equal to 40 off. Transpose natin and then divided by 10. So, we have 35 kilonewton. Then, taking the summation of forces vertical is equal to 0. So, of course, we have 35 kilonewton plus R2 minus 100. So, kunuha ko na yung resultant. So, parehas lang kung 40 and 60 yung gamitin nyo. So, is equal to 0. Therefore, the reaction at 2 is equal to 65 kilonewton. So, this is 65 and this is 35. So, let us draw the shear and moment diagram. So, do we have a concentrated load here? We have, which is 35 kilonewton. Do we have area in the load diagram? Wala. So 35. So do we have a concentrated load here? We have, which is 40 kilonewton. So 35 minus 40, we have 5 kilonewton or negative 5 kilonewton. And then, do we have a area here? Wala. So negative 5 ulit. So do we have a concentrated load here? We have, which is 60 kilonewton. So negative 5 minus 60, so we have negative 65. And then do we have an area here? The load diagram, wala. So 65. So kung papansin nyo, this is negative 65 and this is 65. Kaya mag-close yung ating shear diagram. So connecting all the points. So ito na yung ating shear diagram. And to draw the moment diagram, we have here. So do we have a moment at this part? So wala, 0. Do we have an area in the shear diagram? We have, which is equal to 35 multiplied by this must be 3.5, not 2.5. So 5 minus 1.5, so we have 3.5 here. 3.5. So we have 35 multiplied by 3.5, so we have 122.5 kilonewton dot meter. So do we have a moment at this part? Wala. Do we have an area in the shear diagram? We have, which is equal to minus 5 multiplied by 1.5 plus 1.5 plus 2. So it is equal to 97.5. So do we have a moment at this portion? So wala. Do we have an area? We have, which is equal to minus 65 by 1.5. So we have 0. Ayan, nag-close yung ating moment diagram. So ito yung ating moment diagram. So 1 degree lahat yan. Yan. So the maximum moment. So the maximum moment, Mmax, at 40 kilonewton is 122.5 kilonewton dot meter. So let us proceed naman to the maximum moment at 60 kilonewton. So the maximum moment at 60 kilonewton. So ganun din. Drawing natin yung span. So this is now the center line. So yung 60 kilonewton natin, ito yun. So it is located 1 meter from the center line. 1 meter, so we have 100 kilonewton. And then we have 3 meters. So if this is 5 meters and then 5 meters, so this is equal to 5 minus 3, 2 minus 1, so 1 meter na lang to. And this is equal to 4 meters. So taking the summation of moment at R1 is equal to 0, we have 100 multiplied by 4 minus R2 multiplied by 10 is equal to 0. Therefore, the reaction at 2 is equal to so we have 40 kilonewton yung R2 natin. So this is 40 kilonewton, and taking summation of forces vertical is equal to 0, so we have 100 minus 40 plus R1 is equal to 0. Therefore, reaction at 1 is equal to 60 kilonewton. So this is equal to 60 kilonewton. And then let us draw the shear and moment diagram. So for the shear and moment diagram, do we have a concentrated load here? We have, which is equal to 60 kilonewton. So do we have an area in the load diagram? Wala. So 60 kilonewton. Do we have a concentrated load? We have, which is equal to negative 40. So 60 minus 40. So we have 20 kilonewton. And then, do we have an area? Wala din. So, 20. Do we have a concentrated load? We have. So, 20 minus 60 is equal to negative 40. And then, do we have an area here? Wala. Yeah. So, 40 kilonewton. So, 40, negative 40 plus 40. So, magiging 0 or mag-close yung ating shear diagram. So, ito na yung itsura ng ating shear diagram. This is our shear diagram. And then, we are ready to get the maximum moment. So, drawing natin yung maximum moment. We have a moment here. Wala. We have an area. We have, which is 60 multiplied by 1 meter. So, 60 na lamang yun. So, 60, yes, this is 60 kilonewton dot meter. So, do we have a moment? Wala. Do we have an area? We have. So, 60 plus 20 multiplied by 5 meters. So, we have 160. So, we have here 160 kilonewton dot meter. So, do we have a moment? Wala. Do we have an area? In the shear diagram, we have, which is equal to negative 40 multiplied by 4 meters. So, 0. So, ito yung ating moment diagram. So, 1 degree lang yung mga yan. This is now the moment diagram. Therefore, the maximum moment at 60 kilonewton is equal to 160 kilonewton dot meter. And then, pipili lang tayo dito sa dalawa kung ano yung mas malaki. So, mas nag-govern yung 160. Therefore, the maximum moment is now equal to 160 kilonewton dot meter. So, ito na yung ating answer for the maximum moment. And for the maximum shear, drawing lang natin yung whole span again. By considering 60 meters or 60 kilonewton yung nasa support na. So, we have 60 kilonewton. And then, yung 40 kilonewton natin. So, it has a 5 meter span. And then, this is R1. So, this is also 5 meters. So, by taking the summation of moment at R1 is equal to 0. Therefore, we have R2 multiplied by 10 plus 40 multiplied by 5 plus 60 multiplied by 10 is equal to 0. Therefore, the reaction at 2 is equal to 40 times 5 plus 60 multiplied by 10. Transpose natin and divided by 10. So, we have 80 kilonewton. So, this is 80 kilonewton. So, R1, by taking the summation of forces vertical, so it is equal to 20 kilonewton. So, kung drawing yung shear diagram nito, we have, so do we have an area, or do we have a point load here? We have, which is R1, so 20 kilonewton. Do we have an area? Wala. So, do we have a load? So, negative 20 times 40. So, 20 minus 40 is 20. So, do we have a concentrated load here? We have 20 kilonewton. Do we have an area? Wala. So, magre-retain yung 20 kilonewton. Do we have a concentrated load? We have. So, 20 minus 40, we have negative 20 kilonewton. So, do we have an area? Wala pa rin. So, do we have a concentrated load here? We have, which is negative 20 minus 60, kaya naging negative 80. So, this is negative 80, then 80 kilonewton. So, mag-close yung ating shear diagram. So, ito yung ating shear diagram. Therefore, the maximum shear is equal to 80 kilonewton. So, the maximum shear would now be equal to 80 kilonewton. So, ito yung ating final answer. So, for our problem number 2, repeat the problem number 1 using axle loads of 30 kilonewton and 50 kilonewton on a wheel base of 4 meters crossing an 8 meter span. So, on this solution, I will be showing to you the second way on how we solve the maximum moment and the shear. So, yung first part kanina, we used shear and moment diagram para makuha yung maximum moment. So, on this example, papakita ko sa inyo yung mas madaling paraan on how we solve on the maximum moment and then yung maximum shear. So, kung napansin nyo on the first part, I didn't use the equation na in-introduce ko kanina, but try to check your answer using the given formula that we have. So, makikita nyo na parehas yung sagot. So, we have 30 kilonewton and 50 kilonewton load. So, this is yung 30 kilonewton and this is 50 kilonewton. And yung fixed distance nila is 4 meters. So, this is 4 meters. So, yung resultant, so 30 plus 50. So, the resultant is equal to 30 plus 50. So, it is equal to 80 kilonewton. So, 80 kilonewton. And then, solve natin yung position ng ating resultant. Kung gaano siya kalayo sa 30 kilonewton. So, we have x and we have 4 minus x. So, taking the summation of moment at r is equal to 0. So, we have negative 30 multiplied by x plus 50. Moment arm is 4 minus x is equal to 0. Therefore, the value of x is equal to 2.5 meters. Therefore, this is 4 minus 2.5. So, this is 1.5 meters. So, ilipat na natin siya sa 8 meter span na bridge. So, this is reaction 1 and then reaction 2. And then, ito yung ating center line. So, maximum moment at 30 kilonewton. So, doon muna tayo sa maximum moment at 30 kilonewton. So, dito sa 30 kilonewton, again, drawing natin 30. So, 2.5 divided by 2, so 1.25. This is 1.25. And then 1.25. So, this is resultant P, which is 80 kilonewton. And then, we have, again, distance of 1.5 for our 50 kilonewton. So, yung span natin is 8 meters. So, this is 4 meters and then 4 meters. So, this would be, yung natitira dito is equal to, so, 4 minus 1.25 minus 1.5. So, 1.25 meters. And then at this part is equal to 2.75 meters. So, taking the summation of moment at R2 is equal to 0. So, we have R1 multiplied by 8 meters. Gamitin natin yung resultant minus 80. Moment arm is 1.5 plus 1.25 is equal to 0. Therefore, the reaction at 1 is equal to, so 8x minus 80 of 1.5 plus 1.25 is equal to 0. So, it is equal to 27.5 kilonewton. So, yung R1 natin is 27.5 kilonewton. So, this is taking the summation of forces vertical. So, yung R2 natin is 52.5 kilonewton. So, we will take the moment to the left of 30 kilonewton. So, taking the moment at the left of 30 kilonewton, so we have 27.5 multiplied by 2.75. So, it is equal to 27.5 multiplied by 2.75. So, it is equal to 75.625 kilonewton that meter. So, this is the maximum moment of 30 kilonewton. Moment max at 30 kilonewton. And then, consider naman natin yung 50 kilonewton. So this is the 50 kilonewton and it is 1.5 meters. So 1.5 divided by 2. So we have 0.75. So 0.75. And then we have 0.75 resultant of 80 kilonewton. Then we have 1.25. So we have 2.5. So ito yung ating 30 kilonewton, which is 2.5 meters. So this is 4 meters. 4 meters. 4 meters. So 4 minus 2.5 minus 0.75. So we have 0.75. And then ito naman 4 minus 0.75. So we have 3.25. So maximum moment at 50 kilonewton. So taking the summation of moment at R1 is equal to 0, we have R2, negative R2 multiplied by 8 plus 80 multiplied by 2.5 plus 0.75. Therefore, the reaction at 2 is equal to negative 8x plus 80 of 2.5 plus 0.75 is equal to 0. So it is equal to 32.5. So 0 to. So yung reaction to natin is equal to 32.5 kilonewton. So taking the moment, so let's say moment to the right of 50 kilonewton. So right na tayo, moment to the right of 50 kilonewton. So we have yung R2, we have 32.5 multiplied by 3.25. So it is equal to 105.625 kilonewton dot meter. So ito yung maximum moment at 50 natin. So comparing these two, pipiliin natin yung mas malaki. Therefore, the maximum moment is equal to 105.625 kilonewton dot meter. So ito yung hinahanap ng ating problem. And then again, let's get the maximum shear. So since nakuha natin yung maximum moment at 50, so i-consider natin yung position ng ating 50 kilonewton at the right part. So this is R2, R1. So ito na yung 50 kilonewton natin. So the maximum shear is positioned at the support. So this is 50 kilonewton. And then we have 4 meters bago mag 30 kilonewton. Therefore, taking the summation of moment at R1 is equal to 0, we have a negative R2. So yung distance nito is 8 meters. A negative R2 8 plus 30 of 4 meters plus 50 of 8 meters is equal to 0. Therefore, the reaction at 2 is equal to it is equal to 65 kilonewton. Therefore, the maximum shear is equal to 65 kilonewton. So ito yung ating final answer. So the maximum shear is 65 kilonewton and the maximum moment is 105.625 kilonewton dot meter. So for our last example, a truck and trailer combination crossing a 12-meter span has an axle loads of 10, 20, and 30 kilonewton separated respectively by distances of 3 meters and 5 meters. So compute the maximum moment and maximum shear developed in the span. So here, we have a train moving load. So ang gagamitin natin dito is yung second way, yung tinuro ko kanina, just like example number 2, para mas mabilis yung computation natin. So, nasa sa inyo na kung anong gagamitin nyo sa exam, if it is the first way or the second way around. So, we have 3 moving loads. So, we have 10 kilonewton, 20, and 30 kilonewton. So, this is the 10 kilonewton, 20 kilonewton, and then the 30 kilonewton. So, ito yung mga wheel ng ating truck and trailer combination. So, most probably, ito yung gulong ng ating truck, yung dalawang to, and then yung trailer is on the 10 kilonewton. So, it is separated by a 5 meter distance and 3 meter distance. So, this is for the 5 meter distance and then 3 meter distance. So, the resultant is equal to 10 plus 20 plus 30. So, we have 60 kilonewton. So, ito yung resultant nung tatlo. And it is, let's say, positioned at this point. So, this is the resultant, 60 kilonewton. So, determine natin ngayon kung tama ba yung assumption natin. And dito yung position ng ating resultant. So, let's say this is x. This is 5 minus x. So, taking the summation of moment at r is equal to 0. So, we have negative 10 of 3 plus x minus 20 of x, yung moment arm, plus 30 multiplied by 5 minus x is equal to 0. Therefore, yung distance x is equal to x is equal to 2 meters. So, this is 2 meters. So, this is 3 meters. So, for the maximum moment, at 10 kilonewton, so, drawing natin yung whole span of 12 meters. So, this is the reaction 1, then reaction 2. This is the center line. So, yung 10 kilonewton muna yung unahin natin. So, 10 kilonewton. So, yung span niya is 5 meters. So, it is located 2.5 meters from the center line. So, 2.5. And then, another 2.5 para sa ating resultant. 2.5. Sorry. So, unahin muna natin yung ating 20 pala. So, this is 3 meters. So, 0.5 meters. Tatagpuan natin yung 20 kilonewton. And then, a distance of 2 meters para sa ating resultant na 60 kilonewton. And then, another 3 meters for our 60 or 30 kilonewton. So, this is 6 meters. 6 meters, 6 meters. So, 6 minus 2.5. 6 minus 2.5. So, we have 3.5. So, this is 3.5 meters. And then, yung natira na lang dito is 6 minus 3, 2, 1. So, this is 0.5 na lang. 0.5 meters. So, taking the summation of moment at R2 is equal to 0. We have R1 multiplied by 12 minus, gamitin natin yung resultant, 60 of 3.5 is equal to 0. Therefore, the reaction 1 is equal to 12x minus 60 of 3.5. So, it is equal to 17.5 kilonewton. And then, taking the moment to the left of 10 kilonewton. So, we have R1, which is 17.5 multiplied by 3.5. So, it is equal to 61.25 kilonewton that meter. Ayan. So, Let us proceed to the maximum moment at 20 kilonewton. So, drawing natin ulit yung ating diagram. Pero, nag-move na yung 20 kilonewton natin at this part. So this is 20 kilonewton. So this is 20 kilonewton and it is located 1 meter from the center line. Then another 1 meter for the resultant, 60 kilonewton. And then another 3 meters for 30 kilonewton. Then, yung 10 kilonewton natin is located 3 meters away. So, this is the 10 kilonewton and 3 meters. So, we have reaction 1 and then reaction 2. Tapos, this is 6 meters, 6 meters. So, 6 minus 1 minus 3. So, we have 2 meters pa at this part. And then, we have 6 minus 3 minus 1. So, 2 meters then. So, taking the summation of moment at R2 is equal to 0. So, we have R1 multiplied by 12 minus 60 of 3 plus 2 is equal to 0. Therefore, the reaction at 1 is equal to, so we have 60 divided by 12. So, we have 25 kilonewton. And then taking the moment to the left, of 20 kilonewton. So we have R1 25 kilonewton multiplied by 5 meters minus 10 multiplied by 3. So the moment is equal to 95 kilonewton dot meter. So this is the maximum moment at 20. So this is M max at 10. So ano ba tayong isa? Which is the 30 kilonewton. So we have reaction at 1, reaction at, and this is the center line. So, i-move natin yung 30 kilonewton, 1.5 to the center line. So, this is 30 kilonewton. And we have 5 minus 3 meters. So, this is 1.5. And then, another 1.5 para sa ating resultant of 60 kilonewton. And then, 2 meters away for 20 kilonewton. And then this is 6 meters, 6 meters. So 20 kilonewton and then 3 meters. So makikita natin is lumagpas na yung ating load na 10 kilonewton. So yung 10 kilonewton is somewhere here. 10 kilonewton kasi if 6 meters minus this is 1.53. So, this is 2 meters. So, natitira na lang dapat dito is around 1.5. Tama? So, we have 6 minus 2 minus 1.5. So, 2.5 pala. So, 2.5 meters na lang yung natitira dito. But the distance between 10 kilonewton and 20 kilonewton is 3 meters. So, kinulang tayo ng 0.5 meters. Kasi yung distance nito is 3 meters. So, hanggang dito lang yung ating span. Therefore, ang gagawin natin dyan is ang consider lang natin is the 20 kilonewton and the 30 kilonewton. So, magdodrawing tayo ng isa pang span having the 20 kilonewton and the 30 kilonewton na lang. So, dalawa. We have 20 kilonewton and 30 kilonewton. So, meron siyang resultant which is equal to 20 plus 30. So, 50 kilonewton. So, determine natin ngayon yung distance x. So, this is, yung span ng 20 and 30 is 5 meters. So, this is 5 minus x. So, taking the summation of moment at the resultant is equal to 0. So, we have negative 20x plus 30 of 5 minus x is equal to 0. Therefore, x is equal to x is equal to 3 meters. So, drawing natin. So, ulit tayo ng ating span. So, we have R1, R2. This is the center line. And then, consider natin, this is 2 meters and this is 3 meters. So, i-consider natin 1 meter is 30 kilonewton. And then, yung resultant natin is 50 kilonewton. Then, located 3 meters away is yung ating 20 kilonewton. Yan. So, this is 6 meters again. 6 meters. So, 6 minus 3, 3 minus 1, 6, 4. So, this is 2 meters. Then, meron tayong natitira dito na 5 meters. So, taking gamit lang tayo ng ibang papel for this one. So, taking the summation of moment at R1 is equal to 0. So, we have R2, negative R2 multiplied by 12 plus 50 multiplied by the moment arm, which is equal to 5 meters, is equal to 0. Therefore, the reaction at 2 is equal to, so 50 multiplied by 5 divided by 12. So, we have 20.83 kilonewton. And then, taking the moment at the right of 30 kilonewton. So, right na yung kukunin natin. Kasi ito yung pinakamalapit. Dito yung pinakamalapit na support. So, it is equal to R2, which is equal to 20.833 kilonewton multiplied by 5 meters. So, it is equal to 104.17 kilonewton dot meter. So, comparing the 3 na nakuha natin kanina. So, this is the maximum moment ng ating 30 kilonewton. So, we have this 104 and then yung kanina at 20, 95 and then 61.25. So, yung pinakamalaki is maximum moment at 30. So, the maximum moment is equal to 104.17 kilonewton dot meter. So, ito yung sagot. And then, for the maximum shear, i-drawing lang natin yung ating span. So, since 30 kilonewton yung pinakamalaki, ilolocate natin yung 30 kilonewton at the support. So, this is 30 kilonewton. And then, so kung sino yung pinakamalaki sa kanila, yun yung ilolocate nyo. Or kung sino yung pinakamataas na moment sa kanila, yun yung ilolocate nyo or ilalagay nyo sa support. So, we have 30 kilonewton. And then, yung span niya is 5 meters. 5 meters for 20 kilonewton. And then, 3 meters for 10 kilonewton. So, we have R1 and R2. So, dito sa R2, magkakaroon tayo dyan ng maximum shear. So, taking the summation of moment at R1 is equal to 0. Therefore, we have negative R2 multiplied by 12 plus 10 multiplied by, so 12 minus 8 plus 20 of 12 minus 5 plus 30 of 12, 30 of 12 is equal to 0. So it is equal to, we have 10 of 12 minus 8 plus 20 of 12 minus 5 plus 30 of 12. So, transpose natin, then divide by 12. So it is equal to 45 kilonewton. So yung R2 natin is equal to 45 kilonewton. Therefore, the maximum shear is equal to 45 kilonewton. So ito yung ating final answer.